The next thing I want to do is go through a few of the homework problems for this week. I know these are kind of challenging this week. Remember, if you went through the confidence intervals part 1 assignment in statcrunch, you should be able to do all of these problems using those statcrunch procedures. This is finding a critical value for a confidence level of 81%. So for this one, you could just use the statcrunch normal calculator with the between window, put in 0.81 for the probability, and then what it will give you back is the critical value. For all of these questions, you need to determine which parameter you're trying to estimate. When they ask you to do a confidence interval estimate, if it says an estimate of a percentage, that's the same as doing a proportion. There was a problem like this in the confidence intervals part 1 assignment that we looked at earlier this week. For this one, we've got 297 accurate orders and 58 that were not accurate. So actually here they're not giving you a total sample size, they're giving you the 2 different results. That means when you go to statcrunch and put this in, you're going to have the total sample size, and that's just going to be these 2 numbers added together. If I'm going to do this in statcrunch, since it says I'm estimating a percentage, the procedure I'm going to use is the proportion stats. This is going to be 1 sample, and since they didn't give me the actual data, they just gave me the sample results, that means I'm doing this with summary. The number of successes is the number that correspond to what they're asking for here. If it's the percentage of orders that are not accurate, then my successes would be the number that were not accurate. In this case, it's 58. My number of observations is my sample size. For that, I'm going back to here where I added the 297 and the 58, so my sample size is 355. I'm doing a confidence interval, and for this one it wants 95%, so I'm going to leave that as 95%. And this is giving me my lower limit and my upper limit, which is what they're asking for in these 2 boxes. And for these, you have to pay special attention to the directions. This says express the percentages in decimal form, which means I'm going to leave them in the form they are in statcrunch, and then it says round to 3 decimal places. For my lower limit, that's going to make that 0.125. My upper limit is going to be 0.202. For part B on this one, it's asking me to compare the confidence interval I got here to this other confidence interval that they have. And the main thing you should be looking for here is whether the intervals overlap or not. So there is some overlap between these 2. The upper limit for this one is greater than the lower limit for this one. If you drew these 2 together on a graph, they would have some overlap. What that means in statistical terms is that there's not a significant difference between the 2. So in this case, it would be choice D, where it says that the 2 confidence intervals overlap. Now, if you get a different result where they don't overlap, then it would be one of these other 2 choices. Problem number 10 is asking you to find a minimum sample size. And this depends on 2 different formulas. The one that we used in the Unit 2 project results assignment, that one is if you do have a prior estimate for the proportion. In the first part of this one, they're saying assume nothing's known about the percentage of passengers who prefer aisle seats. If you don't have a prior estimate, then instead of this formula, you're going to use a different formula. This one is in the Chapter 7 notes, but I'm also going to write it for you here. In this case, your minimum sample size, you still have the critical value here that's squared, but then instead of the p star and the 1 minus p star, here you just have a 0.25. And underneath you have the e squared. That's the formula that you'll use in part A for this. So first you have to find the critical value based on the confidence level. That's where you'd go to statcrunch and use the normal calculator backwards. In this one you would just have the 0.25 after that, and then for the E down here, where they say within, that's telling you the margin of error that they want. And since this is 4.5 percentage points, you have to change that to a decimal. So for what I have here, I'd find the critical value that goes with 90%, and for this I'd put in 0.045 squared. And remember, with these you have to round up to the next highest integer. Minimum sample size problems, you're always rounding up no matter what. Once you get that answer, the next part gives you a prior estimate for the percentage. For that, you're going to use the same formula that we used in the results assignment for the Unit 2 project. So here you're still going to have the same critical value that you used in Part A. For this one, your P star is going to be what they give you for the prior estimate. That means in this particular one, I'd take 32% and convert that to a decimal. So I take 32 divided by 100, and that means here I'd have a 0.32, and here I'd have 1 minus 0.32. The E is going to be the same as what you used in the first part, so that's still going to be the percentage points they gave you up here changed to a decimal. This problem is very similar to the last one. They're asking you to calculate the minimum sample size two different ways. First of all, if you don't have a prior estimate, for that you'd use this formula, and then the second part will be if you do have a prior estimate, and for that one you would use this formula. There are also problems in this homework assignment that have to do with finding confidence intervals for means. You can still use statcrunch for this. You just have to choose the right procedure in statcrunch. For these, whenever they're talking about a mean, you're going to use the t-stats. In this one, they just gave you sample data, so you're going to say with summary. And what you get here should match with what they give you in the problem. So they ask for the sample mean, that's the x bar. The sample standard deviation is the s, and the sample size is the n. We're doing a confidence interval, and this one asks for 90%, so I'm going to change this to 0.90. And there's my confidence interval. I've got my lower limit and my upper limit, which are the answers that are going to go into those two boxes. This one, again, they're asking you to compare the confidence interval you got to a different one that they have. And you are looking at whether they overlap or not, or whether the values are similar or close together. In this case, they do overlap, and the values for the lower limits and the upper limits are fairly close together. So you'd say no, they're not very different because the limits are similar. This is the same idea. They're asking you to construct a confidence interval estimate for the mean. So again, you'd be using the t-stats, and they're giving you a sample mean, a sample standard deviation, and a sample size. That means you're doing one sample with summary. For this one, they're not asking you for a confidence interval, they're asking you to find a sample size. That means you're doing a minimum sample size problem. But this one has to do with a mean, so the formula is different. And if you're looking for the formulas for these, you can find them in the Chapter 7 notes. So I'm going to pull these up. Here are the notes from Chapter 7. So we're looking for the minimum sample size formula for a mean. Here are the two ones for the proportions that we already talked about. And here's the sample size formula if you're talking about a mean. Here's our minimum sample size formula. Also in this one we have the critical value. So for that you're going to have to go to statcrunch and use the normal calculator, just like we've done in previous problems. Where it has the sigma star, this is an estimate for the standard deviation, and they give you that in this problem, where they say assume that sigma equals, in mine it's a 22. So I would put the 22 in here, and they also give you a margin of error. For this margin of error, you do not want to change it to a decimal form. This is not giving you a percentage, it's just a value. So in this one, for mine, since it says within 3 IQ points, I'm going to use 3 for my E. The only one where you have to change it to a decimal form is with the proportion ones, where they give it to you as a percentage. But in this one, you don't. So you would take those three things, plug them into this formula, be sure and square it at the end, and be sure and round it up to the next highest integer when you're done. Next in this assignment is finding critical values for the chi-square distribution. This is a new distribution, but there's also a calculator for this in statcrunch. For this one, I'm going to use stat calculators, and there's one here that says chi-square. It's the only one that has a square in it, if that helps you find it. I want to use the between window, and this is going to work just like the ones for my normal calculator. I'm going to take my confidence level and put that in here as a decimal. The only extra thing I have to do with this is that for the DF right here, that's the degrees of freedom, I have to take my sample size and subtract 1. Since this one is 20, for my DF, I'm going to put in 19. And then when I click on compute, it's going to give me the two different values. For this distribution, it's not symmetric, so you do get two completely different values. They're asking you that in two different parts in this question. And this says to round to 3 decimal places, so that would be 8.907 for that one. And then the next one is the one on the right here. This next problem is asking you to find a confidence interval estimate for the standard deviation. This is where you have to use the variance stats procedure in statcrunch, because statcrunch doesn't have one specifically for the standard deviation. So this one is a little hard to get all the numbers in there correctly. You're going to use stat, variance stats, one sample with summary. For the sample variance, they're not giving you that value, so you have to figure it out from what they told you. They did give you the sample standard deviation. To get the sample variance, you're going to take that standard deviation and square it. So I'm going to take 43.7 and square it. That gives me 1909.69. That's what I'm going to put in here for my sample variance. Then for the sample size, since this said there were 16 subjects, that's my sample size. I'm doing a confidence interval, and this asked for 90% for my confidence level. And what this gives you is the lower limit and the upper limit for the variance. So to get the answers to put in here, you have to take each of these two values and take the square root. I'm going to do the square root of the lower limit, and that will give me my lower limit for my standard deviation. And then the square root of the upper limit here will give me the upper limit for my standard deviation. So this one is 33.85 rounded to 2 decimal places, and this one is 62.81. This one is also asking for a confidence interval for the population standard deviation. This one they do give you the data, so you can open it in statcrunch. You still need to use the variance stats because it's about a standard deviation, but this time, since you have the data set, you can do one sample with data. And this problem is going to ask you for the confidence intervals for both of them, so you can do them one at a time, or you can select both of these and do them both at once. So all you have to do with this is select the columns and then put in the confidence level that they asked for. In this one, it's 90%. And then remember, when you get these answers, these are for the variance, so you have to take the square root to get the answers for the standard deviations. This one is similar. They give you the data. You can open this in statcrunch, and since you're trying to estimate the standard deviation, you're going to use the variance stats, one sample with data. And in this one, they're going to end up asking you both for the course evaluations and the professor evaluations. You can do this one at a time if you want to, or you can do them both at the same time. And this asks for a 95% confidence level, so I'm just clicking on that. Again, you have to take the square roots of these answers to get back to the standard deviations.